The third presentation from Woodrow Wilson High School. We have 3 students, Steven Figueroa, Sean Begg, and Angel Lopez. Let's welcome them to the front.
Hello everyone, my name is Steven Figueroa. To my right we have Sean Begg, and across the stage we have Angel Lopez. So beginning this project, it was a one-man team with one mission to find a problem worth solving and potentially find a product that can solve it. So going through this point of the process, it was a bit difficult for me. I couldn't find something that I actually wanted to pursue. I started off by trying to find something that would impact the entire world, such as like world hunger, littering, global warming. But one day, Mr. Carter said, if you're having trouble finding your problem, go throughout your day, see what's wrong, see what holds you back, and see what can potentially be different. I started off in the morning, eating breakfast, nothing wrong. Going to school, nothing wrong. Going through school, everything was okay for the most part. Until I had to go to work at Raising Cane's after school. So as soon as I went there, one of my partners, or one of my crew members, was complaining about a burn that she suffered just simply from grease splashing on her as she was cooking the chicken. So that got me thinking, if I can pursue burns in the fast food industry, then that can lead to something great. So the Burn Foundation has concluded that the fast food industry is one of the top 50 worst for burns. So a lot of their employees are getting burned, and a lot of this is happening more frequently throughout the years as industries grow and more employees continue to get involved in this. But burns in fast food industries are still very broad. You can have a toast burn, a grease burn, you can have someone just touching a heat lamp and getting burned. So I wanted to go more specific, which is why I went to my managers to talk. So I talked to my manager, Melanie. She's the operation manager at Cane's 313. And she had just recently came back from a meeting which involved filtering oil burns. So to get more specific, we went ahead and decided to do filtering oil. So whenever this process, when you go through the process, filtering oil, there's a lot of steps that you take, but that a lot of people end up messing up or missing certain steps, causing them to get injured. So what is filtering oil and what mistakes are made? Filtering oil is exactly what it sounds like. You clean the oil simply because you're cooking in it all day, it's getting filthy, it's turning your oil black, and it's ruining the taste of the overall food that you're cooking. So these are the steps that you take to filter oil, and the ones that are shaded in red are the specific problems that we're going to focus on. So during the process, there's a step where you have to lower the drain into the filter pad, and then from there you pull the blue valve that releases the oil down that drain into the filter pad where it's going to continue to cycle. Now the problem that we're focusing on is people are forgetting to put this drain. People are forgetting to put this drain down, which causes crew members to end up spilling all over their feet, spilling all over the ground, and which eventually leads to people slipping and falling or themselves getting severely injured. At this point, I was given the privilege to work with Sean Bay and Angel Lopez to work through this problem. And as we all know, this is a problem. The only question now was, what can we do?
So we first looked at some products that had already been made. So for instance, the Frymaster, it's essentially just they just innovated by just putting a touchpad and you just walk through the steps. It doesn't actually do anything. Other solutions were just self-filtering machines, and then the last one was just training. But those all have their own faults, such as the self-filtering fryers. They cost a whole lot more, and you'll have to replace every single machine that they've ever bought. The training, people tend to just kind of skip past it, forget it. They're like, oh, that'll never happen to me. And the Frymaster, you can literally just press and just keep going. So here's some patents. These ones are mainly just the self-filtering oil, heat-resistant aprons and stuff, which mainly just protects the individual rather than everyone around them, because once the oil spills, it not only affects the one person, but also affects the people around them. So these are our design criteria. We wanted to, first is price. We want this to be as cheap as possible because we don't want companies to look at the price and be like, oh, this is way too expensive, we can just keep with our status quo. Next is storage. We want it to be as compact so we can easily store it. Next, durability. We don't want this to easily wear out. We want this to be as long lasting as possible to protect people. Size, again, we want it to be as small just so that we don't have to change around any type of structure with like new organization. Performance has to perform the same or better at not only filtering oil but also cooking to make sure that it still tastes the same. Amount of human input, we want to be able to reduce how much human interaction that could cause a person to slip up and actually spill oil. We want to also decrease the number of people impacted. Again, we don't want just a single person to be the only one protected. We want everyone in the area to be protected because people will slip and fall on the oil and they'll even get usually worse burns than the person that caused it. Time, since it's fast food, everything has to be delivered as fast as possible. We cannot essentially slow down the time that it takes for people to cook. Feasibility, we actually, since we're high school students, we have to be able to actually make it, and then ethically, we have to essentially, we can't just make it too outlandish, such as outright banning oil.
So these are the stakeholders and the people who are really concerned with this problem. They need to be aware that we're doing this for them. And they are the people that would be interested in a creative idea that would reduce injuries and that would help their business save money, prevent the business from going under, maybe from lawsuits, from injuries, and all the kinds of problems and reasons that the stakeholders might be attached to this problem. And keeping the stakeholders in mind, we went through a brainstorming process and came up with a list, looked through the list at the kinds of ideas that we had presented to us, and seeing which ideas were good and which ideas were really kind of bad. And we came up with our own solution ideas. We went through a wooden suit. Working with wood was not really a very helpful idea. We looked at air fryers. We looked at how the use of electricity, how much grease would be involved, using a smaller amount of grease, but the food would taste different in that case. We looked at an automatic floor where the floor would open up and the grease would come out immediately if something happened. And we looked at the steel suit, which would be really hot if you got hot grease on it. And it's made out of steel as well, so it would conduct temperature very easily. So we looked at sensor locks. That would relate to when the drain came down and the movement of that. And then we looked at cooling systems. Like you could clean the oil, it would be cooler, and then it could be heated back up when it was time to cook by itself.
So we plugged all that into design solution matrix, and at first we came out with the air fryer being on top. So we decided we catted up a commercial air fryer essentially where it uses multiple compartments that you can just pull out, drop the chicken in, and then close just so that it can cook it. But that came with its own problems, such as we found out that there was an air fryer that actually did all that and better, but there were problems with that as well.
So the reason this was on top of our solution matrix was because it wiped out the entire process of having to filter. But if you think of like a fast food industry with their culture and their traditions and what made them what they are, it's kind of hard to change that. So if we're putting air fryers, then you're not going to have the traditional fried chicken of Raising Cane's that everybody believes. So you're going to decrease in customers. It's possibly it's not even going to taste the same. And you're going to have to retrain your entire crew to cook a different way, learn new methods, and just change your entire tradition that you normally already have. Like we've all said, if Raising Cane's adds gravy, they're going to have $2 million more a year. But they're simply not going to do that because that's what they started with a simple menu, and that's their tradition, and that's what they're going to keep doing. So after retweaking our solution matrix and specifically looking at the price of the commercial air fryer, we decided that sensor locks was the highest, and that's what we would potentially try to pursue. So the final solution that we've decided was the sensor locks, which is an IR sensor that detects the drain that I mentioned before, and the blue valve that relates to the drain. There will be a mag lock attached to the pivot, and they'll be paired to work with each other to know when to unlock the valve to let the oil release and when to not. And that's just a quick diagram to see how the whole process would work. So for our prototype, we wanted to make a section of the fryer that is relative to the one that the pickup fryer that Raising Cane's originally has. So on the bottom right, you can see that's a model that we found like a sheet from the pickup fryers, and we decided to make this centerpiece right here because that's all we needed to prove our point. We have the drain here, and the blue valve is located right above.
So here's what the skills that we needed to perform what we were going to do. We needed to have some programming skills, soldering skills, and the other things you see in front of you. Here's a list of materials. We had to use wires, we had to use an IR sensor, we needed a mag lock, we needed batteries, we needed an Arduino, we needed connecting wires, and those sorts of things. So here we are working on our prototype at Stephen's house, and we were doing some cutting. We were working with wood. We needed to do a prototype mock-up on how all of it would work with an actual fryer. But unfortunately, we didn't have a lot of tools. And we needed to make a circular opening, and we had to make multiple drill holes to perform that task.
So just going forward with the construction, if you were to look at the image on the far right, exactly where the laser pointer's at, that's where the lever is placed, and right behind it at the pivot is where the mag lock would be. So the IR sensor is located right there. As this drain moves up and down, if the IR sensor detects a drain at the lower position, which is when it's pushed down, then it will send the signal to the mag lock to unlock. Therefore, you're allowed to pull the blue valve, and the oil can go into the filter pad, not on your feet or the floor. So for our Arduino circuit design, we used this model that was given to us by Matt Wolfgang, which is just my neighbor who loves to do Arduino projects for fun, simply because that's just what he likes to do. So he sent us this model, and we used it to make our Arduino circuit simply by replacing the light bulb with the mag lock and using the thermistor replacing the thermistor with the IR sensor.
So this is us working on the electronics. We wired up an Arduino with an IR sensor. We had an external 9-volt battery and a voltage regulator for our 12-volt, which the mag lock ran off. And we had one of our major setbacks was we had a 12-volt relay which at the time we didn't fully understand what the relay did. So we were trying to push 9 volts through it, in which by the off chance that we accidentally fried the 9-volt relay by pushing a little bit too much voltage into it. We did a little bit more research this time and found out that we actually needed a 9-volt relay to make it so that the relay would be able to switch. And so we also coded in the Arduino language, which is Java. Well, it's C++, but it's really reminiscent of Java, with a really simple if-else statement. If the IR sensor detects the drain, then unlock. Otherwise, it'll always stay locked.
Okay, so testing our prototype. So when testing our prototype, we ran 4 trials consisting of 20 tests each. So for the first one, it was normal speed, which I'll get to that, about how fast that is a little later. So the first test was normal speed, and success would be if as soon as if the IR sensor detected the drain and unlocked the mag lock. And then I ran another one with fast speed, one with the power being turned off and on after each test to see if it was consistent, and then distance, just simply moving the IR sensor back to see if the distance would affect it, as well as tweaking it, not just setting it to a distance and moving back. So this was normal speed. This is originally supposed to be a video to see the speed because it's kind of hard to describe, but I'll try my best. It's just moving it at a constant speed up, holding it up for like a second, going back down, just a simple motion. So with this trial, we had a 70% success rate and a 30% failure rate. Now, with the failure rate, it was just like wiring slipping. And as soon as that happened, I just hooked the wiring back up. And we did have 2 key errors, which was 12 and 15, which was the program flipped. So instead of the IR sensor detecting the drain and unlocking the mag lock, it would lock it. And then we ran the test fast speed, and it was pretty much a bit more difficult. Wiring was slipping, and the exact same problem was occurring. However, it was a 50-50 with success rate compared to failure rate. And with noticing whenever the circuit wires would slip and the program would flip, it was pretty much the same as like turning the power off and turning it back on. So that's what I tested here. I turned the power off and then turned it back on in each trial, and the program did what as expected, and it flipped. So for this trial, we had a 55% failure rate and a 45% success rate. And then for this test, I just tested the distance. So we had a 100% success rate when the IR sensor was within 5 centimeters of the drain, and 2 out of 5 when it was 10 centimeters, and the rest was failure. I believe it was simply because it was pushed further back. However, Sean has more to say about that.
So after a little bit more research and fiddling with the IR sensor, one thing that I realized is that on the IR sensor there's a light that detects, that shines whenever it detects something. That is, however, not the case whenever you push the IR sensor past a certain distance. After, I think, 10 centimeters, it'll actually flip. So whenever the light is showing, that means that it doesn't detect something. And whenever it turns off, that means that it detects something. So in order to solve that, that's most likely just fixing the code so that if it's in that distance, then we can just essentially just reverse the if else statement.
So moving forward, we have to continue this process and make improvements and make our product better in the future and possibly be able to set up a business, distribute it worldwide so that people can be safer and have a goal of success in saving lives and injuries.
Yes, and when moving forward with this project, the errors that we had during our testing there's someone out there in the world that can fix it. I know there is. Our program being flipped, I know someone can help us with the coding. We can get more advanced IR sensors or a mag lock that can work a bit more efficient to get 100% success rate. Because I always look back to the first trial we did, and I had a 70% success rate, and that was with, I believe, 4 of the trials having just wire slipping. So if we can possibly contact anybody, help us make it wireless, we can make this product something that can actually be used in a Raising Cane's restaurant and save many young students or old adults while they're filtering oils.
Also, we'd like to thank all the mentors, Mr. Tolson and Matt. They really helped us a lot. Matt donated the Arduino and some basic wirings to help us out, and Mr. Tolson actually helped us figure out mainly how the coding worked and just giving us hints as to where to go.
We also want to thank our class, our EDD classmates, simply because as we were presenting these certain elements throughout the year, we were giving feedback, and actually there was sometimes the project goes wrong, but then they helped us bring it back up, move forward, and then shout out to Mr. Carver. He was consistently challenging me simply by saying, prove it, or we'll see if it works, and I moved forward. There's a famous quote he says where you got to go outside these 4 walls, and that's exactly what we did, and thank you for that, and any questions?
Is this working?
First off, I just want to say, from a professional standpoint, and especially as a judge, is it Angel specifically? I'm sorry. Yeah, you could have easily not talked at all. You could have kind of just sat off the side and let your friends talk. So the fact that you had a translator for yourself and for us, I was deeply impressed that you put in that effort and went like that extra step forward to present. So thank you.
Thank you.
I would say a really excellent job on the presentation. Really liked how you laid out the different sketches of your ideas and how to solve the problem, everything from the wooden suit up to what you did pick. Did you share the solution with the people at Raising Cane's, with your manager, and what were their thoughts?
Yes, so I quit. Right before I started, I was a month into this project, and I quit. But I did share with them before, like when you were trying to solve a problem, prove it. They didn't give me feedback simply because they simply said that it would be detrimental for like a loved one to get hurt. Because like in a restaurant, a lot of people don't think about it, but we all build relationships, and we see more, especially when you're there for a long period of time, we see each other more than just friends. And they gave me feedback on that. I surprisingly, I will be returning in May, so I will be talking to them about that. And, yeah.
Okay, on that note, I would like to add that if you have anything that deals with safety like this, and you're talking about your justification, if you can throw in like a personal story, it doesn't have to be personal. If you can throw in a story about an individual that was affected by this, it's always impactful. So, something to keep in mind. I want to say, I guess, Angel came up and, shook all of her hands in the beginning. Now, that's not always feasible with time and stuff for groups to do, but he had the opportunity and he did it, and so I appreciated that. And by far, when you had the slide up there that talked about your detailed solutions and with the image, I don't know who's running the computer, but oh, there you are. Okay, so yeah, if you can just go to that. That is a powerful engineering project right there. When you have it to where the brainstorming is that detailed and you have that many solutions that you've talked about. Running with your first solution is very easy, but you had it up there, I think, a couple times already. But that is wonderful. Like, I don't know if I can do this with the teachers, but I gave you a bonus point for that. So I hope that they give you that bonus point. Very, very impressed at the design work, the design thinking behind this project. Good job.
Thank you. Any other questions?
All right, our final project of the day is from North Dallas.